Okay, let's talk about some issues that can arise in the context of sharding. The most obvious thing to keep in mind is that after MongoDB 3.4, you can have up to one migration per pair of shards, one sourcing the chunk and one receiving it. Here we can see exactly that happening. And if you have 6 shards, you could have as many as 3 chunks in flight, if 3 of your servers have too many chunks and the other 3 have too few. One problem that can arise is if you end up getting jumbo chunks. If a chunk grows large enough without being split, it becomes a jumbo chunk. The sharded cluster won't try to move it as the chunk could be in flight for too long. MongoDB will also stop trying to split the chunk. Jumbo chunks often come from having a shard key with insufficient cardinality, meaning that there's no shard key value it can split on. By default, in a sharded cluster, the chunks should be split at 64 megabytes. Let's do an example. We're setting up a sharded cluster with 3 shards. Each shard is a replica set with 3 members. Great. Let's connect and shard a collection. We'll enable sharding and shard on last name, first name for the example collection. Great. Let's look at sh.status. So all of my data, such as it is in a single chunk, but that chunk is empty. Let's insert a bunch of documents all with the same shard key and create a jumbo chunk. I'm going to make the documents 1 megabyte each by creating a string that's 1 megabyte in length. Okay, so all of my data is now in a single chunk and it can't be split because it all has the same shard key values. Let's look at sh.status. There it is, 1 chunk. Obviously, this is a bad shard key if I can do this, but let's deal with some of the fallout. We'll try adding some more data, this time on a different value. We'll use the name Norberto Late. Okay, so now I have 200 documents of about a megabyte each. And if I look at sh.status, I can see that I've still only got 1 chunk on 1 shard. All of my reads and writes are going to hit this 1 shard, and none of them will hit either of the other shards. So I've got an imbalance. Let's see what's going on in our server logs. Okay, I can see the sharded cluster is starting out. Request split points. If I scroll down a bit, requests it. Possible low cardinality key detected in m312.example. Key is last name cross, first name will. Okay, so the server already knows I have a bad shard key. Now I've got a couple of choices here. I can try to manually split the chunks, say with sh.splitat, or I can increase the chunk size. First, I'm going to split it manually. Great. Let's look at sh.status. Okay, so now I have 2 chunks. Each of them are 100 megabytes, and I'm still not balancing them. They're both just staying on my 1 shard. To fix this issue, I'm going to try to move a chunk manually. And MongoDB is telling me no, the chunk is too big. Okay, let's try to increase the chunk size. We can do this by modifying the chunk size directly. Usually when we do things like this, we would use a helper function, but as of this recording, we need to actually modify the config DB, something that isn't to be done lightly, but it is necessary in this case. I'm going to set the value at 150 megabytes. Good. Once again, let's look at sh.status. My chunks still haven't migrated. Let's do one more split to wake it up and get it going. And we'll look at sh.status. Okay. And if I do that again, great. 3 chunks, and they're distributed. Now, just to be clear, one of those chunks contains no data, and I was able to migrate my jumbo chunks by changing my chunk size. This isn't going to help if I have a bad shard key like I do here, because I'll just continue adding documents to those shard key values, but that's something you can do in cases where you get stuck. Now let's create a bunch of chunks and let the cluster distribute them. sh.status. And OK. Whole lot of chunks, and it's distributing them. And after a few moments, I have a nicely balanced cluster with 10, 9, and 9 chunks respectively on each of those shards. But of course, my data isn't evenly distributed. There's a great helper function in the shell to assist us with looking at our data distribution. It's called db.collection.getShardDistribution. Let's check it out. Okay, so what am I looking at? Shard02 seems to have 200 megabytes. Shard03, none. Total 200 megabytes, 200 chunks. There you go. Shard02 contains 100% of the data in the cluster. I can use this information to figure out if I need to split chunks on my own, figure out if I've got a problem with my shard key, etc. And that's how to look for and fix some basic issues in a sharded cluster.